Hi, Assalamualaikum and a very good morning. So now we are in chapter 9, which is carbonyl compound. And we're going to focus on the subtopic of 9.4, which is chemical properties, part 1 of the video. So in this video, we're going to look and explain the chemical properties of the carbonyl compound. And then we're going to look into the reaction that it underplays, which is first nucleophilic addition, where it can undergo nucleophilic addition with the reactant of HCN, water, alcohol, sodium bisulfite, as well as the Grignard reagent. The carbonyl compound can also undergo reduction where it will be reduced into alcohol using a reducing agent of lithium aluminum hydride followed by hydrolysis, sodium borohydride in methanol, as well as using hydrogen gas as the part of the hydrogenation reaction using a catalyst, for example, platinum, or nickel, either one of those. Next, we're going to see the condensation reaction. So we're going to do that with the ammonia derivative, and this can also be done as the identification test. Last but not least, we're going to do the oxidation reaction using a strong oxidizing agent, which is the KMnO4 at high temperature at acidic condition or using the chromic acid here. Okay, so without any further ado, let us start. So for carbonyl compound, it will undergo four reaction, which is nucleophilic addition, condensation, oxidation, and reduction. So for now, we're going to look into the nucleophilic addition first, and then we're going to follow up with condensation. And on the last few slides, we're going to focus on oxidation and reduction, where both of these processes are interrelated to one another. Okay, so now let us look into nucleophilic addition first. So for the nucleophilic addition reaction, it basically is a reaction that will be undergone by the carbonyl compound. This is because the C double bond O that the carbonyl have will have the different electronegativity, where oxygen is more electronegative than carbon, and this causes the oxygen to carry a partially negative charge and the carbon going to carry a partially positive charge. Okay, and this causes the nucleophile, which is rich in electron and has the negative charge or lone pair, gonna attack the partially positive charge region here. And this is why the carbonyl will undergo the nucleophilic addition reaction. So the nucleophile that we're gonna look at is first using HCN, where it's gonna be produced in situ, okay, secara terus, when the KCN react with the sulfuric acid. Next, we're also going to look into the nucleophile of sodium bisulfite, which is NaHSO3. We're also going to look at water, alcohol. Okay, so R here can be any alkyl group, for example, CH3OH or an aromatic alcohol, also doesn't matter. And then E is a Grignard reagent here. Okay, so let us look into A first. So for the addition of HCN, what we're going to do is that the HCN going to be prepared in situ secara terus by the reaction mixture of KCN or NaCN with the sulfuric acid. So the product of the reaction between our carbonyl compound with HCN going to produce a cyanohydrin. So let's say if we have a carbonyl compound here, and then you react with NaCN in the presence of H2SO4, the reaction of this one and this one essentially will produce HCN. Okay, and we cannot write HCN directly without these two substances here, because HCN is very, very corrosive and it cannot exist as its own. Okay, so that is why we need to add up NaCN and H2SO4 in order to produce HCN in the reaction bottle, and then you only react that with the carbonyl compound. Okay, and as you know, the HCN will have Cn minus and H plus here. Okay, so the Cn minus will act as a nucleophile and attack here, and the double bond gonna break and attach the hydrogen. Okay, so the mechanism, you don't have to know the mechanism, but essentially the Cn gonna be attached here, and the double bond O gonna become OH. Okay, so Cn akan masuk di bawah, and the double bond O gonna become OH here. Okay, and this is why we got HCN. Okay, and this product is known as the cyanohydrin. Now we're going to do another example. Let's say if we have the aldehyde here, which is the benzaldehyde, and then we're going to react the same one, which NaCN at acidified condition. So what you're going to expect by this reaction is that CN going to be attached here, and double bond O going to become OH. Okay, and this product is known as the cyanohydrin. Now let's say if you have a ketone here, or known as the propanone, and then you're going to react with KCN with H2SO4. These two reactions will produce HCN, the same as before. Okay, so CN going to enter here, and double bond O going to become OH. Okay, and this product is known as the cyanohydrin. Okay, so that's all for the addition of HCN. Now we move on into the addition of sodium bisulfite, which is NaHSO3. So the reaction between aldehyde and NaHSO3, sodium bisulfite, going to produce a bisulfite salt. So this reaction is basically used for the purification penulinan aldehyde dengan ketone from other non-soluble organic compound. So sebenarnya the ketone that we produce are essentially not pure enough. So usually we're going to react that with the bisulfite salt in order to get a pure substance. However, this is just for your information here why we're going to react with the sodium bisulfite. Okay. So we have our carbonyl compound here, which is a ketone, and then you're going to react with the bisulfite salt, which is the sodium bisulfite. And then what you're going to do here is almost similar to the previous slide, where SO3 2 minus going to attack here, and as a result, it will become SO3 minus when it attach, and the double bond here going to become OH here. Okay, and because it's become SO3 minus and this one become H plus, the sodium metal, because it carry a positive charge, will be close by to the SO3 minus here in order to neutralize the charges. Okay, and this is going to be named as the bisulfite salt. Okay, so let's look into another example. For example, we have ethanol, and then we're going to react with the sodium bisulfite. SO3 going to enter here. This one going to become OH. Okay, and at the same time, the sodium metal going to be attached close by to it. Okay, so if you want to put your SO3 at the down here, doesn't matter. Okay, you want to put at the side also, it's still the same meaning. And this is known as the bisulfite salt. Next, we have our propanone, which is a ketone, and then we're going to react that with the sodium bisulfite, and our SO3 minus is going to be attached here, and here going to become OH, and then at SO3 minus, they're going to be attached with plus here. Okay, and this is going to produce a bisulfite salt. Alright, so that's all for the sodium bisulfite reaction. Now we're going to focus on the addition of water to the aldehyde or ketone. So via the reaction of aldehyde or ketone to water, what we're going to produce is the hydrate, or known as the germ diol. Okay, so now let us look into the general reaction. So let's say if we have our ketone here, or the carbonyl compound here, and we're going to react that with water, what's going to happen is that the OH going to be attaching here. Okay, and then this is going to take up the hydrogen. So as a result, there are going to be two OH group on this side. Okay, OH here and OH here. Okay, and that is why the blue color here. Okay, and this happens at the acidified condition. Alright, and this situation, this product here is known as the hydrate or germ diol. So the meaning of germ is basically comes from the words germinal, where it means that there are two OH group bonded to the same carbon. Okay, and the short form is germ. Okay, now let us look into another example. Let's say if we have our methanol here, and then we're going to react that with water at acidic condition, what we're going to produce is OH on this side and OH on this side. Okay, So this is known as the hydride or germdiol. The same situation here. Let's say if we have our butanol. Okay, so when butanol react with water at acidified condition, we're going to produce OH here and OH here. So this is also known as the hydride or germdiol. Okay, now we're going to do the reaction of carbonyl group, let's say aldehyde or ketone, but now we're going to add it with alcohol. Just now we add water, right? Now we're going to add alcohol. So when we add alcohol, they're going to form hemiacetal or hemiketal. If we proceed, we're going to produce acetal, and then when we proceed, we're going to produce ketal. Okay, so let us look one by one. So let's say if you have your aldehyde here, and then you're going to react that with alcohol, so ROH. So you know that, for example, CH3OH, the OH bond can be broken, and OCH3, where O going to carry a negative charge, going to attack here, and this one going to take up the H plus here. Okay, so what they're going to happen is that they're going to attach with OR and OH. Okay, in the presence of acid, they're going to produce a hemiacetal, OR and OH. However, when we are using a ketone, and then we're going to react that with the same alcohol at acidified condition, what we're going to produce is OR here and OH here. Okay, so what we're going to produce is hemiketal. Okay, for hemiacetal comes from aldehyde. Ketone means hemiketal comes from ketone. Okay, where these have both alkyl group. Acetal only have one alkyl group, and the other one going to be hydrogen. Okay, and we can use this one and react it again. Same goes to hemiketal. We can also react with more alcohol group in order to further react it. So we're going to look about it at the next slide. So hemiacetal and hemiketal in acidic solution can react further to form acetal and ketal. So this one is the hemiacetal that we have produced just now. So from this slide here, so I bring it back to here, and then I'm going to react with ROH. So what it's going to do is that the RO here going to replace the OH. So it's going to produce with 2 OR and 2 OR here. And this, from hemiacetal, it will be named as acetal. Okay, so hemi maksudnya adalah separuh, hemisphere. Okay, but now because OR and OR has been fully bonded to the carbon, it's going to be a full name. So it's going to be acetal instead of hemiacetal. Okay, so same goes to this situation. So we have R and R here. So with one OR, so it's going to be hemiketal, separuh. And now it's going to react with alcohol at acidified condition. So OR can enter here in order to replace the OH. So this one going to produce a ketal. Okay. So this is the summary of addition of alcohol that I have talked just now in the two slides. So from aldehyde, it can produce hemiacetal and then produce acetal. From ketone, it can produce hemiketal and then to form ketal. Hemi means separuh. And now this one become full. Okay. Now we're going to look into the addition of the Grignard reagent to the carbonyl. So this one is basically the same as what you have learned in the chapter of haloalkane, where your Grignard reagent, you can react with methanol, aldehyde, and ketone, where both of these things is represented by the carbonyl compound. So when a Grignard reagent react with methanol, we're going to produce a primary alcohol. Second one, when we have our Grignard reagent, CH3MgBr, our CH3 here going to attach here, and this going to produce a secondary alcohol. And if the granite reagent react with ketone, it's going to produce a tertiary alcohol. Okay, so this is the addition reaction of the carbonyl compound. So we have looked into the nucleophilic substitution reaction. Now we're going to look into the condensation reaction of the carbonyl compound. So now we're going to look into the condensation reaction of the carbonyl compound with the ammonia derivative. So a condensation reaction is basically a chemical reaction in which two molecules combine in order to form a larger molecule. Okay, and this happens with the elimination of a smaller molecule, for example, water, ammonia, or HCl. Okay, and we're going to focus on the ammonia derivative. So ammonia derivative here mean it is a compound that has a substituents that replacing one of the hydrogen of the ammonia. So you know that ammonia, which is NH3, will have 3 bond with hydrogen, and then it's going to have a lone pair. And now we're going to change one of the hydrogen into Y, which is another substituent. So the substituent here, I can change it into R group or CH3. Okay, so once I do that, I'm going to get NH2, or is known as YNH2. So Y here can also be changed to OH to become NH2. Okay, so let's look at that. So ammonia generative is basically represented as this one, which is YNH2, where one of the hydrogen going to be changed with another substituent. So Y can be any alkyl group, so it can be an amine, or Y can be an OH group, so it can be hydroxylamine. Okay, and Y can be changed with another NH2, so it's gonna be hydrazine. Okay, and this hydrazine gonna react with the carbonyl compound. So the ammonia and its derivative gonna act as a nucleophile, and this process will involve addition reaction followed by dehydration. So they're gonna be two steps. Pertama addition, kedua dehydration or elimination. Okay, so dehydration means that eliminate water. And the product of our reaction of carbonyl with ammonia going to producing an imine. Okay, so let's say if we have the carbonyl compound here, and then we're going to react with our ammonia. So ammonia will act as a nucleophile, and this is going to attack the partially positive charged carbon. And as the result, this is going to take up the hydrogen at the plus sign here. Okay, so it will undergo addition reaction, and then it's gonna produce COH and then NH3. Okay, so basically it's gonna be something like COH, NH, H plus, and then R and R. Okay, but then one of the hydrogen gonna be broken down so that it become neutral, and that is why it become like this. Okay, and at the end, okay, so this is going to form a structure of carbonyl amine, which is a very unstable intermediate. So in order to make it more stable, what we're going to do is we're going to remove OH and hydrogen here. So we will undergo the elimination reaction, which is we're going to eliminate water. So OH and H going to be eliminated out. So as a result of the elimination of water, double bond going to be forming here. So it's going to become RCR, which is here. And then this C and N going to form a double bond. And then NH. Okay. And this is the steps, which is two-step addition and elimination. However, the mechanism here is not required for your level. The mechanism is not required to be shown during the exam. Okay, not required. So it is just for your understanding. Okay, and this is going to produce a product of imine. And what we're going to eliminate is water, which is OH and H. All right. Now we're going to do the example of the reaction of the carbonyl with ammonia derivative. So let's say if we have a cyclopentanone, which is a ketone, and then we're going to react that with amine, which is a primary amine. So what we're going to do is that we're going to remove the hydrogen, two hydrogen here, and then with the oxygen here. So oxygen and H2 going to be removed, where it's going to be written as the byproduct of H2O. And then the balance here, you're going to form as CnCH3, as shown as here. Okay, you don't have to show the mechanism, but essentially the idea is that you remove two hydrogen and oxygen in order to produce water. Okay, so this happens at acidic condition, and this is going to produce our imine here, and then we're going to eliminate water. Okay, now we're going to look into the second example down here, which is our ethanol. So when ethanol react with the hydroxyl amine, so as mentioned, we're going to remove hydrogen, two hydrogen, and then one oxygen here. Okay, and what's balanced is NOH. So N gonna form a C double bond N here, and then it's gonna attach with OH. Okay, so it becomes CNO, CH3 and H here. So this is gonna produce an imine. Okay, so you can put it upwards or you can also put it downwards. It is still the same meaning. And this is gonna produce imine, and water gonna be removed. Okay, so we're going to do the other one, which is down here. So here we have the propanone because of 3 carbon, and then we're going to react it with N2H4, which is hydrazine. Okay, so N2H4 is basically N and N attached together, and then it got H2 and H2 here. Okay, so as mentioned, we're going to remove hydrogen, 2 hydrogen, and we're going to remove oxygen here. And then we're going to attach our C double bond with N here. So it's going to become C double bond N dash NH2. Okay, so this is going to be our imine at the end. So at acidified condition, we're going to produce our imine here. Okay, so we can put it downwards and CH3 upwards as here, or you can also maintain it like this. And this is going to produce the byproduct of water. Okay. Now for the oxidation reaction, the carbonyl, which is the aldehyde, will undergo oxidation, and this gonna happen when there is a strong oxidizing agent. For example, the hot acidified KMnO4, or the potassium dichromate, sodium dichromate, or the chromic acid with the presence of heat. So, but the product of the oxidation reaction of aldehyde gonna produce a carboxylic acid. So let's say if we have our aldehyde here, and then we're gonna react that with a strong oxidizing agent, which is KMnO4, at high temperature in the presence of heat, what we're gonna produce is a carboxylic acid. Okay, so this is the reaction of aldehyde into carboxylic acid. However, for ketone, CH3 here, CH3 here, it cannot be oxidized. Dia tidak boleh dioksidasikan. Okay, only aldehyde can be oxidized. Okay, and now we're going to look into another example. Let's say if we have 1, 2, 3 here. So we have our propanol. When we react with a strong oxidizing agent at acidified condition at high temperature, what we're going to produce is a carboxylic acid, which is a propanoic acid. Also, if we use another type of aldehyde, which is cyclopentyl methanol, and we react it with a strong oxidizing agent at the similar condition as above, which is acidified and high temperature, what we're going to produce is a cyclopentanyl methanoic acid. Okay, so the idea is from aldehyde into carboxylic acid. Okay, aldehyde and carboxylic acid. Ketone cannot be oxidized. Now, we're going to look into the reduction of the carbonyl group. So, reduction can happen when there is a reducing agent, for example, lithium aluminum hydride followed by the H3O plus or the hydrolysis of water. Second, we have the sodium borohydride in methanol, which is CH3OH. And the third part is the catalytic hydrogenation, which is we're going to use hydrogen with the presence of catalyst, which is platinum, or hydrogen with nickel. The other metal that you can use is platinum is also okay. Alright, so there are three options for the reducing agent. So let's say if you have a propanol here, which is 3 carbon, and you're going to react that with a reducing agent of lithium aluminum hydride, followed by hydrolysis, which is H2OH plus, which is H3O plus. What we're going to produce is a primary alcohol. Okay, so here is a primary alcohol, and this is known as 1-propanol. At the same time, we can also react the acetophenone, which is a ketone, but with a benzene ring. So when we reduce it with using the catalytic hydrogenation, which is H2, in the presence of nickel catalyst, what we're going to produce is a secondary alcohol. Okay, so double bond O here going to become H, and then here become H with a single bond here. All right, so everything that just now you have learned about in the previous chapter, you have learned about alcohol being oxidized into aldehyde using PCC, and now the aldehyde can be reduced back into propanol. So now we're going to look into the summary once again. Okay, and this is going to be known as phenylethanol. So here is the summary of the oxidation and reduction. Okay, in the previous chapter, which is chapter of alcohol, so you have your primary alcohol. So you can undergo oxidation with a strong oxidizing agent. You're going to form a carboxylic acid. At the same time, your primary alcohol, you can undergo a mild oxidizing agent with PCC in order to form aldehyde. And this aldehyde also can undergo further reaction to form carboxylic acid. So you have looked into this reaction in chapter 8, which is the hydroxy compound. Similar to this one, secondary alcohol, you can undergo oxidation in order to form a ketone. Meanwhile, tertiary alcohol cannot be oxidized. Okay, and just now you also have looked about the oxidation of aldehyde, which can happen, and oxidation of ketone cannot happen. Okay, and for the fourth reaction, you learn about reduction. Okay, so here is oxidation, here is oxidation, here is oxidation, and here is oxidation. However, you just now have learned about reduction, where you're going to use reducing agent. So basically, your aldehyde here can also be reduced back into alcohol using a reducing agent. So it's basically the reverse way. Oxidation, reduction. Okay. The same time, you have learned about ketone can also be reduced into secondary alcohol. So we can make another arrow here. So oxidation, alcohol to ketone to alcohol, secondary alcohol, we can undergo reduction again. Okay, so I think that's all for today's video. See you again some other time. Bye!